students. So today we will be continuing with the chapter Physical Quantities and the Measurement. So far we have completed most of the topics of this chapter. But today in this session we will be discussing some of the topics that were not taught to you. So some of those topics what we are going to discuss today are determination of density of a liquid, the density bottle, determination of density of a liquid, using a density bottle, relative density and their units, and density based some numericals. So these are the topics what we will be covering today in this session. So I hope you pay attention and watch the video till the end. So as we all know what the density is, we have already discussed about the density in our previous class. The density of a substance is the mass per unit volume. This means that for the given volume, what is the mass that is contained in a body, or what is the material of a body that is contained in it, we consider that ratio as a density. So far we have already learned how to find the density of a solids. So usually to find the density of the solid, what we do? We measure their mass by the use of physical balance or bin balance, and we measure their volume either by the use of appropriate formula. If the shape is regular like cube, cuboid, cylindrical, conical, if the shapes are proper geometrical shapes, then the volume is calculated by the use of its appropriate formula. But if the shapes are irregular, like a stone, which do not bear any shape, right? For such irregular shapes, to find the volume, we make use of displacement method, what we have already learned. And once we are equipped with mass as well as volume, then the density is calculated by the formula mass by volume. Provided if the mass is in gram, we usually take the volume in centimeter cube, so that the unit of density becomes gram per centimeter cube. Or if the mass is in kg, then usually we take the volume in the unit meter cube, so that the density will have a unit kg per meter cube. Now you are already aware that this kg per meter cube is the SI unit of density, whereas gram per centimeter cube is the CGS unit of density. So these are the topics what are already covered in the previous class. Now today we will be learning about the determination of a density of a liquid. Now how do we determine the density of a liquid? Now to determine the density of a liquid, we make use of the formula mass by volume. The formula remains the same. Now in order to measure the mass of a liquid, we either use a physical balance or we use a bin balance. But the problem is, we cannot measure the mass of the liquid directly as we do for a solid. And what is the reason? The reason is, liquid has a tendency to flow. Now owing to that reason, we cannot directly pour the liquid on the bin balance. If we do so, the liquid will flow. The liquid will fall out from the bin balance. Hence now, how do we measure the mass of the liquid then? Hence, there is an indirect method by which the mass of the liquid can be determined. Mind you, when I say a liquid, it includes water as well as other liquids. Okay? So now, to measure the mass of a liquid, what we first do is, number one, we take an empty container. Okay? So what do? We take an empty container and we measure its mass using the physical balance or a bin balance. Now once we measure the mass of the empty container using the bin balance or a physical balance, we will mark this as M1. So we have marked this mass of an empty container as M1. Then what we do is, we will pour a certain volume of a liquid in this container. What do we do next? We now will pour the liquid whose density is to be determined in this container which is empty. And once this container is filled with that liquid, again we will measure the mass. Number 2, what we do is, we'll pour the liquid in an empty container and measure its mass. Okay? So initially what we did, we took one empty container, we measured the mass of that empty container and we labeled that mass as M1. Now in the next step, we fill that container with the liquid. Once we fill that container with the liquid, we again measure the mass of that container along with the liquid in a beam balance or a physical balance. And we consider that mass as M2. Now what is M1? It is the mass of empty container. What is M2? It is the mass of the container plus the mass of the liquid. Now, in step 3, to measure the mass of liquid only, that means to know what is the mass of the liquid taken, what we will do is, we will find the difference of these two masses. That is, from the mass of the container plus liquid, we minus the mass of empty container. So what is M2? M2 is mass of container plus mass of liquid minus what is M1? It is the mass of empty container. Now, this mass of container and this mass of empty container, one is positive, one is negative. So these two will get cancelled. So what are we left with? We are left with the mass of the liquid. So this way we can determine the mass of the liquid by the indirect method. Because directly to measure the mass is not possible. Now once we know the mass of the desired liquid, then we will measure the volume of that liquid by the use of measuring cylinder. Right? There are various other tools that can be used to find the volume, which is graduated. We can even make use of a Eureka can. Am I right? Hence, by the use of such devices, we make use of those devices to find the volume. And once that volume is known, so in the next case, what we do? Number 4, measure the volume using measuring cylinder. Can you see here? Measure the volume using a measuring cylinder, or else you can use a Eureka can, right? You can use the other tools to measure the volume. And we will label this as V. Now once we know the volume, we know the mass, then the density of that liquid can be obtained by the formula M2 minus M1 by V. That is mass of liquid by the volume of liquid. So dear students, this is the activity. In fact, it is one of the activity that can be performed in the lab in order to find the density of any liquid. But provided we need to know what is the method of finding the mass and what is the method of finding the volume. Okay? Once again, if I recapitulate, what do we do first? We take one empty container and we measure the mass of the empty container, M1. Then we pour the liquid in that empty container. We again measure the mass, we will label as M2. Then the mass of the liquid is obtained by the difference of M2 and M1. Now once we know the difference, we get the mass of the liquid. Now what is left is to find the volume. So to find the volume, what we do is we make use of a measuring cylinder or a Eureka can or other volume measuring devices to find the volume of that liquid. And once we are aware of the mass of the liquid, once we know the volume of the liquid, then the density can be calculated by the formula m2 minus m1, which is mass of liquid by V, that is volume of liquid. So this is the first topic what we have discussed today, that how can we measure the density of a liquid. Now let us move on to the next topic. So the next topic what we are going to discuss today is, as I have already mentioned in the board, the next topic is your density bottle. So what is the next topic? Density bottle. Now this density bottle is also called as a specific gravity bottle. We also call it as specific gravity bottle. Okay? So these actually are the simple glass vessels. So when a question comes, what is a density bottle? What is a specific gravity bottle? Why do we use this specific gravity bottle? Why do we use a density bottle? Then the simple answer is, the density bottle is a small container made up of glass with a narrow opening at the top, and this top is called as neck of the bottle. Okay, so if I draw, the density bottle somehow looks like this. Look here. This is how the density bottle looks like. You can see it is made up of a simple glass, a thin glass, and it has a very narrow neck. Now through this narrow neck, we pass a stopper. Stopper is a lead that prevents the flow of a liquid. Okay? This stopper is usually made up of cork. Now this stopper has a very fine hole here. There is a very fine tube, let's say. Now what is the purpose of this fine tube? When you fill this bottle with the liquid, and when you place the stopper in the neck of the bottle, whatever excess liquids are there in the bottle, it will drain out of this hole through the stopper, and only the said amount of liquid will be left here, which means that the volume of the container remains always same. Okay? So what is it? This density bottle will always have a fixed volume. It is because if any excess liquid is filled in this bottle, that excess liquid will drain out of this hole. Because of that, every time a fixed amount of liquid will be contained in a container. Okay? Then now the question comes, what is the purpose? So we have learned about the density bottle. What is the density bottle? It is a container made up of glass with a narrow opening at the top, which is called as neck. Now this neck is provided with a stopper. Stopper is usually made up of cork, and this stopper has a very fine capillary in between, which aids out to drain the excess water that is filled in a liquid. So that if any excess liquid is filled in a bottle, it drains out through that stopper. Now, what is the purpose of a density bottle? Usually, this density bottle is used to determine the density of a liquid. Again, the same thing. In the previous topic, we have learned how we can measure the density of the liquid, right? In which we measure the mass of the liquid, and to measure the volume, we took the measuring cylinder. But in this case, when we are using a density bottle, there is no need to find the volume using the measuring cylinder or a eureka can. The density bottle itself will aid to find the volume also as well as the mass. Now let us find out how we can measure the density of a liquid with the help of a density bottle. But one thing, what we need to know about the density bottle is that you must know that the density of water is 1 gram per centimeter cube, which always remains same. So in CGS unit, the density of the water is always 1 gram per centimeter cube. Now see here, what is density? This mass by volume. Now if this density of water is 1, then it will be mass by volume. Hence your volume will be equal to mass, which means that the mass of the water in the density bottle is always equal to the volume of that bottle. Hence here, by the use of the mass of the water, we can find the volume of the liquid also, since this mass of the water contained in the density bottle gives the volume of that container, which always remains fixed. Hence for a density bottle, as the density of the water is 1 gram per centimeter cube, this clearly means that for every mass of water that is contained in that container, it gives you the volume of a water or a volume of that container. So let us find out now, how can we measure the density of a liquid by the use of density bottle? So, measurement of density of liquid using relative density bottle, or we also call it as specific gravity bottle, or simply a density bottle. Number one, what we first do is measure the mass of empty bottle. Remember here, when I say empty, the bottle should be completely dry, because a small portion of the water, small droplets of the water also will increase the mass of the bottle, owing to which the numerical value of the density of the liquid may not be correct. Hence, when we are measuring the mass of the empty bottle, we need to make sure that the bottle is completely dry. So we measure the mass of the empty bottle and we call this as M1. Number 2, now we fill the bottle with water. Remember, it's not a liquid right now, whose density is to be determined. We'll first fill this density bottle with the water so as to find the mass of water. And once we know the mass of the water, that will be the volume of that density bottle. So, we first fill the bottle with water and measure its mass. And this mass will be taken as M2. So, what is M2 now? M2 means mass of water plus mass of empty bottle. Correct? We have class 2, M2. And what is mass 1? It is just the mass of the empty bottle. Now, once we measure the mass of the bottle filled with water, right? Number 3, we again fill the bottle with a liquid. Now what do we do next? Once we measure the mass of the container along with the water, we will drain out the water. Again, we will make the container completely dry. And once the container is completely dry, now we will fill the same bottle with the liquid, whose relative density or whose density is to be determined. Okay? So what we are going to do? We are going to fill a bottle with the liquid. And now measure the mass of liquid with bottle. That is empty bottle. So we measure now the mass of the liquid along with that bottle, and we will measure this as M3. So we have 3 different masses here now. M1 is the mass of an empty bottle. M2 is the mass of the water along with that same bottle. Mass M3, the mass of the liquid along with the mass of that same water, same volume. Now once all these 3 are done, then what we do is, Then once this is done, we'll first find the mass of water. This mass of water will be given by M2 minus M1. That is, mass of the bottle along with water minus the mass of the empty bottle. This will give me the mass of water. Similarly, now we'll find the mass of the liquid. Mass of liquid will be given by M3 minus M1. That is, mass of a liquid along with the bottle minus the mass of the bottle. Now, once we know this mass, we know the mass of the liquid, we know the mass of the water. Now we know that as the density of water is 1 gram per centimeter cube, this implies that the mass of the water is equal to the volume of an empty bottle. That is the volume of a bottle which contains the liquid. And therefore, the density of liquid is given by the formula, the mass of the liquid by volume of the liquid. Mass of the liquid by the volume of liquid. So now, what is the mass of the liquid? The mass of the liquid is M3 minus M1. Now, what is the volume of the liquid? The volume of the liquid is equal to the volume of that container or the density bottle. And the volume of the density bottle is always equal to the mass of the water that is contained in that bottle. That will be M2 minus M1. So this way we can find out the density of any liquids, taking water as a reference liquid there. Because without water, we cannot find out the volume of that density bottle. So in order to determine the density, of a liquid, we need to know two quantities. One is the mass of the liquid and one is the volume of the liquid. And that volume of the liquid is determined by this formula M2 minus M1, which is equal to the mass of the water, which is equivalent to the volume of that density bottle. So this way now, we have completed even the hot topic here. Now let me give you one example based on this. Okay? Let me say now, I have the mass of empty container. So let's say the mass of empty container is 10 gram. Okay? Okay, 10 gram is very less. Let's say 50 gram. This is the mass of empty container. Then what we do next? We fill water in this empty container. So here, mass of water with container, let us say it is 100 gram. Okay? So this one is my M1, this one is my M2. Now third, we will replace this water by a liquid in the same bottle, and let us say the mass of liquid with container, let me assume it is 150 gram, that is M3. So now what is the formula for the density of a liquid? Since we are using a density bottle, it will be M3 minus M1 by M2 minus M1. So what is M3? 150. What is M1? 50. By what is M2? M2 is 100. Again M1 is 50. So this will be 100 by 50. This will be 2 grams per centimeter. So this is the density of the liquid what we are taken in this example. Now today, the next topic, what we need to discuss is relative density. What is it? The relative density. Now, what is relative density? So far, we have learned about the density, right? We know that the density is the mass per unit volume. But what is relative density? And what is the importance of the relative density? And why do we need to calculate the relative density? What is the significance of that? So if you come to that topic, before we know what is the importance of the relative density, we need to know what actually the relative density is. Now this relative density is actually a numerical value, okay, a pure numerical value which do not possess any units. If I define the relative density, this relative density can be defined as the ratio of density of a substance to the density of water. This means a relative density is simply a comparison of the densities of any substance with that of water. Okay? Hence here the relative density can be defined as the ratio of density of the substance to the density of water. That is, the relative density will be equal to density of substance by density of water. Is this okay? Now here, what is the importance of relative density? The relative density, in fact, determines how many times the given substance is denser than that of water. For example, if I say relative density of a substance is 5. So relative density of a substance is 5. What does this signify? This signifies that the density of a substance is 5 times the density of water of same volume. This is the importance of a relative density. So here you can see, you can compare the density of a substance with that of water. So just by this numerical value, we can easily see that how many times the given substance is denser than that of water. It can be more denser than water, it can be less denser than water. It depends on the substance what we have taken. Right? If I say the relative density is 0.9, this means that the density of a substance is 0.9 times the density of water. This means the substance is less denser than water. But if the value is above 5, above 1, then we can say that the substance is more denser than water. So here, we clearly make out one rule out here. If relative density is greater than 1, okay, then in this case, we can say that substance is more denser than water. Is this okay? But if the relative density is lesser than that of 1, then in that case, substance is less denser than water. Is this clear? Done? Okay. Now, as we have just now learned that the relative density is given by the formula density of substance by density of water. Now, in this case, what is the formula for density? Mass of substance by volume. Now here, if I consider this density of a substance as mass of substance by volume divided by mass of water by volume, right? Because the density is given by the formula mass per unit volume. So if I rewrite this density of a substance as mass of substance by volume, and if I rewrite the density of water as mass of water by volume, and consider that we have taken equal volume. What we have considered here? We have considered that we have taken equal volume. Then in this case, the same relative density can also be written as mass of substance of any volume. Mass of substance of any volume by mass of water of equal volume. Hence, the relative density is not only defined as the ratio of density of substance to the density of water. It also can be defined as a mass of a substance of any volume to the mass of water of equal volume. So this is what we know about the relative density. Now in relative density, there are some facts what we need to know. What are those facts? Let's find out. The relative density of any substance will be equal to the numerical value of density in CGS unit. Okay? So the relative density of any substance is always equal to the numerical value of density in CGS unit. So let us find out. For example, let us say that the relative density of some substance is 7. Remember? Then what we do is, we take this as density of substance by density of water. Am I right? But what is the density of water? The density of water is 1 gram per centimeter cube. Is it true? This means that this can be rewritten as density of substance by 1 gram per centimeter cube. And if I cross multiply this, the density of substance will be equal to 7 gram per centimeter cube. Hence here what we found is that the density of a substance in CGS unit is always equal to its numerical value of relative density. But this is only true in case of CGS unit. Let us see what we can do if the unit is in SI unit. Now, in other words, if we take the SI unit, what do we say? We take the SI unit, then in that case, the density of substance in SI unit will be equal to 1000 into relative density. Now see here, we know that the relative density will be equal to density in CGS unit. Am I right or not? But if the density is in SI unit, then the same expression will change into 1000 into relative density. Now why are we multiplying with 1000 here? It's because to convert the CGS unit into SI unit for a density, the difference is 1000. So we need to multiply with that 1000. So this is one of the important facts. So let us try to understand this with the help of one example. Okay? So let us consider that density or relative density of substance is 7.5. So this is a relative density. It does not have any units, as I have already said, because it is a pure ratio. So the relative density of substance will be 7.5. So its density in CGS unit will be 7.5 gram per centimeter cube. There will be no change. But its density in SI unit will be 7.5 into 1000 kg per meter cube. This will be equal to 7500 kg per meter cube. So this is how we can find the density either in CGS unit or in SI unit whenever the relative density of substance is given to us. So this way we will end this topic, the relative density. Now the last topic that we will be discussing today is density of substance in different states. We will briefly learn about this one. Now you know that when we are talking about the states of matter, there are three states of matter: solid, liquids and gases. Now in solid, the molecules are very tightly packed, right? It is just like allowing 500 students to sit in one classroom. Can you imagine? When there are 500 students confined in one of the classroom, even there will be no places to move. You simply can vibrate, but we cannot move freely from one place to the other because there is no space there, right? So in the solids, also the same thing happens. The molecules are very, very tightly packed in a given volume, owing to which there is a very, very minimum amount of space available for them to move, owing to which the free movement is not possible. So they only keep on vibrating. But if you talk about a liquid, in liquids, the molecules are tightly packed, but not as that of a solid. Because here, they have some room in order to move freely. Because the intermolecular space is quite larger than that of solid, and the intermolecular force of attraction is weaker than that of solid. But if you consider a gas, in gases the molecules are very, very far away from each other. Hence they have a large amount of spaces to move from one point to the other point freely. And that is because in our gases, the intermolecular space is very large, whereas the intermolecular force of attraction is very, very least. This makes a sense that the molecules are not equally or in the uniformly arranged in all the three states. The arrangement of the molecules within the matter, within the volume available to them is different. In solids, the molecules are very tightly packed. In liquids, they are quite loosely packed. Whereas in gases, they are very, very loosely packed. Now, this also counters the difference in terms of density as well. Right? So, if you talk about the density of a substance in different states, we will find the density is different. So, in solid, the density is high, or we can say it is the highest. Whereas in liquid, the density of a liquid is less than solid. Whereas in gases, the density is least, the minimum. Gases has a least density. They are very, very less dense. Whereas if you talk about solid, they are highly dense. But the liquid always will have a density lesser than that of solid, but the density will be higher than that of gases. So this clearly implies that the density is not equally arranged or equally distributed in every state of matter. The density is different for the different states of matter.